Okay, so we will be recording this part of the session. So if anybody has any objections with us recording, please say so now. Okay, thank you. Okay, so let's start going through these problems. And I suggest we begin, let's start with the problems in section 4. I want those two problems to get covered because those problems had to do with the last or latest topic that we were reviewing. So I'd like for us to cover those. Let's see. So we had a couple of problems there. Problems 20 and 30. Okay. Does anybody want to show us problem 20? Let me write that one down here. For problem 20, we had y equals -1. Minus this absolute value of x. And for all of these problems, they're asking us to find the x and y intercepts and also do the sketch the graph. Okay, so who wants to do this one? Let's have some brave volunteers, or I will have to volunteer any of you guys. So who would like to explain this one? If nobody else says anything, I am going to ask.
I can do it if you want.
I can do it, Professor.
Perfect. Let's see. We've got 2 volunteers. That's great.
No, Estrella, it's okay.
Andrea can do it. Okay.
So we're gonna have a competition here. No, who wants to go then?
Estrella, it's okay.
Okay, Estrella, go ahead. Either what would be if you would like to draw it here, that would be fine, and we can explain it. Go ahead. Perfect.
But I just got a y-intercept.
That's correct.
Let me. I don't know what happened to my computer.
Having some technical difficulties.
Okay, now annotate. All right. No.
Let me help you out here. Let me draw the XY plane that we're going to be using.
Yes.
Okay, and we're also talking about finding the x intercepts.
Okay, already.
And
okay.
Over here, let's talk about the y intercepts. Okay, and go ahead.
I'm sorry.
Very good. Okay, perfect. So the y-intercept is in -1, and I'm going to help you. I'm going to help you out here. Okay, I'm just going to help you out. So the y-intercept is going to. I'm going to put it in the same color you did. Is -1. Okay, correct. Now, what happens with the x-intercept? You mentioned that you hadn't found an x-intercept. That's correct. But why is that? Let's see what we have.
Okay. Horrible.
This is just a bit fun for me because it's torture for me to try to draw on the screen, and I just want you guys to experience that it's not that easy.
So this can be an x-intercept because an absolute value can be negative.
Correct. Very well. Very good, Estrella. I'm going to help you out here a bit. When we want to find the x-intercept, we are trying to, or we make the function equal to 0, and we solve for x. Now, but when we're trying to solve for x here, we're going to have this situation. We're going to have the absolute value of x equals -1. That's impossible. Okay, so this means that there are no x-intercepts. Okay.
So that.
Okay, correct. So that means that the graph is not going to cross the x-axis in any way. Okay.
Will be something like this.
Perfect. Perfect. Very good, Estrella. And how to, perfect, Estrella. Thank you very much. Now, I just want to, because we're recording this and so we see the steps. This is very good, Estrella. So what we're going to do now is that I just want to go through the steps of how we got the graph. Okay.
Okay.
So, and that's, I'm going to do that here. So X, this is the base graph. And so I'm going to draw it in different colors. So don't change anything there, Estrella, leave it the way it is. So this is the original graph. Okay. It's a straight, I'm going to make it a little bit more marked like Estrella did. It's a straight line. Okay. Then we have the absolute value. What does the absolute value do? The absolute value turns anything that's negative is going to be now positive. And so the absolute value is going to be like this. Next up, we have a minus here. The minus is going to change everything that's positive, negative, so everything's going to flip. And now we're going to have something like this. And lastly, we have a -1 here. And what does the -1 do? It's going to shift down 1 unit, and we have the red graph, and the red graph is the final one. Okay, perfect. Very well done, Estrella. Thank you very much. Perfect. Okay, questions with this one?
Teacher, I have a question. Yes. When it asks you to give any numbers at which the function is discontinuous.
Okay, so for these particular cases, that question, Lisa, when it asks for the function to be discontinuous, it's usually when we're talking about the piecewise functions, the functions that have sections. Okay, so when you have a function that has sections, you might have something like this, and I'm going to draw it here on the bottom. You might have a function that, for example, goes something like this. Boom, 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 for example, right? Because you're doing it in sections, okay? So for those cases, there's going to be a part of the graph. Do you notice there, Lisette, for example, that if I said that this was, I don't know, this was -3, just to give a number, and this one over here was 2. I would ask you, Lisa, in what parts of this graph here on the right, the function is discontinuous? What does discontinuous means? It means there's a break in the graph. In what part of the graph is there a break?
In the numbers from -3 to 2.
Correct. That would be, for those cases, that's what they're asking you for. Okay. In these other graphs, like the one we just did, the graph is completely continuous. There aren't any breaks in the graph. So there aren't any sections where it's discontinuous. This is mostly going to occur when we have the piecewise functions. Okay.
Thank you.
Okay. Good. Okay. Any additional questions with problem 20? No? Okay. Now I'm going to clear this in 5, 4, 3, 2, 1. Boom. And now I want us to do problem 30. And for problem 30, can somebody please tell me the function that we have there?
Absolute value, square root of x minus 2.
Perfect. Square root of x, and the minus 2 is outside?
Yes.
Perfect. Thank you so much. Now, can somebody please help us out doing that one? Same procedure like Estrella did very well. We're going to hire her to do tutoring in math, and maybe be a teacher in the future. She did very well. Anybody want to do this one? I'll give this one a shot. And if there are no volunteers, I'm going to have to volunteer somebody to do it. So anybody, remember that if for any reason it's incorrect, we're gonna work it out here. So somebody.
I can do it, teacher.
Perfect. Thank you so much, Lisa. I like volunteers that don't have to be volunteered. So thank you.
I don't know how to write.
Okay. So in the either top or bottom part where you've got the menu, there should be a part that says more options. Where you've got the Zoom menu, where you've got or where there should be a part that says more options. And then there's a part that says annotate.
Yes.
Perfect.
No, like that.
Professor, you're muted.
No, it's correct, Lisa. I was just correcting you. You missed the square root here. Okay. Perfect. So it is 4, right? 4. Okay. Perfect.
Professor, there you just take everything out of the absolute value.
Yes, that's a good observation. Yes, because we're interested in the value for the x-intercept. By the way, while I'm explaining this, Lisette, you keep going, okay? Yes, Andrea, because when we're talking about the x-intercept, we're only interested in the value that makes it 0. So remember that the absolute value of 0 is 0. So whenever we're finding the x-intercept, we're really just interested in what's inside the absolute value.
Okay, thank you.
Perfect, Lisette.
2 here.
It would be 2, correct. So we're going to have the intercepts. We're going to have, I'm sorry, an intercept in x equals 4. I'm just going to mark that here to help you out in the graph, Lisette. So it's going to be 1, 2, Yes, go ahead, Lisa.
On the part that you erased, you put square root of 2.
Oh, of x. Yes, that's true. I'm sorry about that. This should be x. Correct. Thank you for that. Square root of x. And we've got a 4 here, and the y is 2. So these are going to be the intercepts. Okay. Now, how could we go about? If you want, Lisa, you can just draw the last part of the graph, and then I can do the explanation of each of the steps, or however you want to do it.
I don't know if it's
Okay. You think it's like that, like that?
no. I don't know if it's correct.
Well, let's review that and let's see why we need to change that. First off, we mark the intercepts, right, Lisa, in 2 and 4. That means that the graph has to cross those points. Okay, so let's go through it step by step. Okay, and you're going to help me out here. First off, let's look at the base function. The base function is this one that we have here. Okay. If we were to graph this here, what would it be like? Is it clear that it would be something like this? Right? Are we okay up to that point?
Yes.
Okay. And then what's the next thing we have here? We've got a -2. Lisa, what does the -2 do to the graph?
Moves to the right.
No, because it's outside of the absolute value. I'm sorry, it's outside of the square root. If it were inside the square root, it would move it to the left or to the right, but it's outside of the square root. And since it's outside of the square root,
For them.
Can you say that again, please?
It moves up or down.
So if it's a -2, where is it moving?
Down?
Down, correct. So it's going to be moving down 2 parts here to -2. Okay, and so it's going to be going something like this. Okay, it's going to be going something, I want to draw it correctly. Okay, it's going to be going down 2 units. Okay, are we okay up to that point? And lastly, what do we have here? We have the absolute value. What is the absolute value going to do to the function?
Makes it positive.
So it's very important. The absolute value, anything that's below the x-axis is going to have to flip upwards. So, and whatever is up on top of the x-axis, that stays the same. So this part is going to stay the same. And this part that's here on the bottom that crossed in -2 now is going to cross in 2. Okay. So the pink one would be the complete function. And it has to be congruent with the 2 values that we found for the intercept. Okay. Is that part clear?
Yes.
Okay. Questions with this one? No? Okay. Good. So if there aren't any, oh yes, I think Diego wants to ask something.
Yeah, Professor, I think the one you flipped it's wrong. Because it needs to go down, but like I think it's like this.
Oh, well, oh, okay, let me, if we want to be strict, yes, it's What you're indicating is the concave. It's concave upwards. So yeah, if we want to, yeah. So instead of going, so the curve is downward. So it would go. What you mean is that it would go kind of like this, right?
Yes.
Okay, correct. Thank you, Diego. So it's an important observation. Instead of it being concave downwards, it's concave upwards. Okay, good. Okay, thank you very much, Diego. Okay, so additional questions with this one.
Teacher, why is it backwards? Well, concave or whatever.
Well, the way I drew it to not be exact. So if you look at, I'm gonna draw it larger, or I'm gonna kind of try to do a zoom. Okay. So I'm gonna be looking at this part here. So in the original graph, it's going like this. What we say when we mean concave is that the curve, this part here, is going downwards, okay? And so if I want to flip that, then I have to do it like this. Okay? The thing is that I had drawn it like this, and that's why technically it was incorrect. So the only thing is that the curve is going, since in the bottom the curve is going downwards, when we flip it, the curve has to be going upwards. Is that clear, I think, Lisa?
Yes.
Good. Thank you. Okay, questions with this one before we move on to the next ones? Okay, I'm going to clear in 5, 4, 3, 2, 1. Boom. Let's do one of the problems in section 3. Who would like to do one of those? In section 3, we've got the compositions and all that. So let's do 8 and 10 are very similar. Let's do 8. And in 8, we've got two functions. One is f of x equals 1 divided by x squared minus 9. And g of x is equal to square root of x plus 4 divided by x. So they're asking us to do all of the operations. Who'd like to do these? So let's do them here on the bottom. So we've got f plus g let's see, who wants to volunteer to do these before I volunteer somebody? If nobody volunteers, I'm going to pick somebody in 5, 4,
I can do it.
3. Perfect. I was going to pick you, Andrea. Anyway, good. It's good that you volunteered. Help us out with these, please, Andrea. At least with these 4.
Okay.
Which are the 4 basic operations. Okay. You can write down the final result if you want.
Oh, okay.
Or the whole procedure. You can write down the final result and I can help explain.
I think it's very big, with me.
That's fine. You can make it as large as you want, and then I'll write down the rest here. So go ahead.
Ready. Professor, do you hear me?
Yeah, sorry, I was muted. Yes, perfect. This would be the addition. Okay,
Yes.
okay, perfect.
It's very like horrible, but sorry.
No, it's not horrible at all. So it's F plus G. This would be the addition. Sorry about the barking. My dogs get kind of crazy, and then my daughter starts answering them, and that makes it even crazier. So that's the addition. That's perfect. Now let's do the subtraction. You can do it down here, and then we can start. We can change and erase. Okay.
Yeah. Uh, ready.
Okay. Very well. Very good. And this would be F minus G of X. And one thing that they're asking us for, and I'm going to take a pause here before we do the rest, is that they're asking us also for the domain of the result. Now, remember that for the domains, again, the definition of the domain is going to be all of the possible values of X according to the function that we're given, okay? And remember that we're going to have two restrictions, okay?
I do
I'm
it.
sorry, I didn't notice my video was up. If you want, if you haven't, then go
I
ahead.
have of those, I think.
And it's the same domain for both of them, actually.
Yes.
If you exactly. Okay, perfect.
Ready.
Okay, perfect. So basically, this is very important because we're linking everything up. So basically, we've got, remember that for the domain, we've got the restrictions. What are the restrictions? We can have a 0 in the denominator or square roots that are negative, okay? So this is the first part. Part of the domain has to do with the fact that for the denominator, which is something that Andrea wrote down here, for the denominator, X cannot be 0 and it cannot be 3. That's perfect. That's correct. Okay. What are we also missing that we have to also consider in the domain? Because we already verified that the denominator can't have a 0. What else do we have there in both expressions that we have to be mindful of? Andrea, look at the expressions that you got. What are the two restrictions that we have to look at in the domain? That a denominator can't be 0, and we can have a square root that's 0 also. So do we have any square roots there?
Yes, but in the numerator.
The square root cannot be negative anywhere. Okay, so the negative square root, that can never happen Never, never, never.
So I have to
Okay.
put
So
another one.
this is correct. Okay. This is correct, but we're missing that we also have to consider the restriction of the square root. Okay. So this is correct, these two values, but we also have to include that, use another color. We also have to include that x plus 4, which is what's inside the square root, has to be larger than or equal than 0. Okay? And this means that x has to be larger than or equal than -4. Okay? Is that part clear?
Yes.
So the complete domain for these functions would be from -4 to 0. This is going to be included. This is going to be excluded. Then from 0 to 3, the 0 and the 3 are excluded because of what we found here on the top, and from 3 to infinite. Okay, that would be the complete domain of the function. So always remember, when we're looking for domains, we need to verify that the denominator is not 0, and that the denominator is not 0, and that the no square root is negative. Okay, that's very important. Okay, very good. Questions with these two before we erase and do the rest? No? Okay. I'm going to clear these. I'm not going to clear all of them. I'm just going to clear part of them. And I'm gonna use part of what Andrea wrote here. If we're going to be doing the product or multiplication of the two functions, the product or multiplication of the two functions, then we would have this function multiplied by this one, and we would have, what would we have here? How would we complete this, Andrea? For the multiplication? I'm leaving some things here drawn so you don't have to write everything.
I annotate.
Yes, please.
Okay. Like that.
Mm-hmm. Perfect. And we've got something similar here for the division. In this case, we don't need the 1 because we have a 1 multiplying, so we can just leave it like that, and that's correct. And actually, the domain is exactly the same one, if you notice. The domain is exactly the same for this one. Okay, perfect. Now the division. How would the division look like?
Like that.
Mm-hmm. Perfect. And we're basically using what's commonly called in Latin America the tortilla rule. And you probably know the tortilla rule when you from school before, but basically if we have a fraction divided by a fraction, God, I hope you know what I hope you guys know what I mean when I'm saying the tortilla rule, or else This is very concerning. If I have A divided by B divided by C divided by D, and so the tortilla rule says that these two multiply and generate the numerator, so it's going to be A times D, and these two multiply and create the denominator, which would be B times C. Okay, and that's what Andrea is doing here. Okay, now one thing here, the domain for the first case, the domain is exactly the same. Okay, why? Because we've got the same restriction in the denominator, x can't be 0 and x can't be 3. But and we've got the square root. So this domain that we wrote down here applies to this one also, okay? But what happens with this one here? Would the domain be exactly the same, or would I need to modify something in the domain?
The person
Please
is
look at for you or for anybody that can identify the answer. So this is the domain for this one because it's exactly the same restriction. The square root can't be negative and the denominator can't be 0.
You will
What happens with this one here?
They will both have to be not equal to 0, no? Because they're in
Correct. Correct. Very well. So what would I need to modify in this domain here to make it congruent for the second one, for the division?
You don't have to include 4 minus 4.
Correct. Correct. The -4 has to be excluded. So the domain for this one is going to be exactly the same domain, but the -4 would have to be excluded. Okay. Correct. Very good. Okay. Questions with this one? Okay. Lastly, before we go, let's do, I believe it also asked for the composition. Did you do the compositions also, Andrea?
No, I think they
Or
don't.
it only asks for the adding and subtracting and that?
Yes, and the division and multiplication.
Okay. Let me just do an example of the composition just to have it here as an example. I'm gonna erase this one. Okay, I'm gonna erase this. And remember then, oops, let me leave that there. Remember that when we have the composition of a function, it means that we are including one function within the other. Okay, so remember what we did there. So it's if f is this one here, I take the place where the x was. So in this case, it's x squared minus 9. And I'm going to grab g, and now that's going to be here. Divided by x. Okay. If we were to just simplify this, just to do that part of the explanation, this is elevated to the square, so the square root is eliminated, and we're going to have x plus 4, and the denominator x to the 2 is x squared minus 9 and the 1. And now for this, we can have a common denominator here, and say that this is equal to x plus 4 divided by x squared would be the common denominator, minus 9x squared. And lastly, we would have, using the, again, the tortilla rule, x squared, and we would have 9x squared plus x plus 4. Okay? I'm going to erase this. Now, this is a different function than the ones we had. So what would the domain be for this function?
Professor,
How,
why did you put an x squared on the numerator?
okay, so what we're doing here, Andrea, again, is the tortilla rule, for lack of a better term. So are we okay up to this point here, Andrea?
Yes.
So the 1 is the same as having 1 divided by 1. Is that clear?
Okay, yes.
And so it's basically, again, it's the tortilla rule. At least I always knew it as the tortilla rule. That's the way it's called. I don't remember why. I don't know why. Don't recall why it's called the tortilla rule. But these two generate the numerator. These two generate the denominator. Okay. Now, what would the domain be? The only restriction in the domain is that the denominator, which is this one here, cannot be 0. Okay. So 9x squared plus x plus 4 cannot be 0. Okay. So we would need to find the roots for this expression. I don't believe that it can be directly factored. Okay. So we would need to use the general formula just to do this quickly. So the general formula is x1 and 2. And somebody help me out here with the calculations. Would be minus b, which is minus 1, plus minus the square root of b squared, which is 1 to the square, minus 4a, which is 9, and c, which is 4. I didn't try it if we could factor that one or not. And 2 times a, which is 9. Okay, and this would give me the two roots. Okay, and these would be the values that would have to be excluded from the domain. So this would be
Professor,
minus,
but isn't the domain can be all the numbers?
the only, well, yes, but I'm going to get to that. There's a reason for that, and it's correct. And the reason is the following. What happens with the square root here? It's going to be 1 minus, can somebody help me out with the calculations here?
144, I think. So minus 143.
Correct. I'm going to trust Andreas's calculations. Divided by 18. So what happens here? We've got a negative square root, right? What does that mean? It means that there are no real, there are no real roots. What does it mean that there are no real roots? It means that there are no values that exist, no real values that are going to make the expression equal to 0. Okay? Whenever we get an imaginary root, that means that there's no value that can make it 0. Or if this were a graph, it would also mean that the graph would never cross or intersect It would have no x-intercepts like we've mentioned. So exactly like I believe it was Viviana mentioned, I think. The domain for this function would be all of the real numbers from minus infinite to infinite. Okay? Because there's no value that's going to make the denominator 0. We don't have any square roots or anything like that. Okay? Okay. Questions with this one? Okay. Good.